All right, I think we can get started. Okay, I'll give a quick 30-second introduction to myself. My name is Rajith. I'm the CTO for Roli. Been around open source for a while. Prior to Roli, I was at Red Hat for a number of years working in engineering. These days, I hang around the OpenCast and OpenTelemetry projects, pretty interested in observability. 2-second intro to Roli, which is we do observability for Kubernetes and cost management for Kubernetes. All right, so let's talk about cost management. So the first part of my presentation, Jonathan covered it. The second part, I think Mary has covered it. So maybe I should just stop. Good. There's always opportunity for cost management. Fun fact, about 2.5 years ago, we were looking at getting better visibility into our own Kubernetes clusters. We used OpenCast, and then we ended up realizing that there was about 15 to 20% savings that we could make. We went deeper and deeper into it, and eventually turned it into product. And we joined the OpenCast project and started going down that path. But that kind of shows. But at the time, we had, 4 to 5 years worth of Kubernetes experience, and we thought we knew how to run optimized workloads. It turns out that there is opportunities for anyone to optimize. Right. I'm going to talk about 3 things. We'll talk about why cost management by looking at the fundamentals of Kubernetes cost management. We'll dive deeper into the challenges and then finally talk about how to overcome these challenges. Good. Why cost management matters? If you're managing a budget, the slide is for you. This trend, this is from the SysDig report. This trend certainly jives with what we see with our own customers in terms of trend. And then this particular metric, 69%, Jonathan talked about it too. And yesterday when we were having a chat, he mentioned 30%, 40% utilization. I'm being generous. But most of the time we see very low CPU utilization. CPU is a very expensive resource compared to memory. There's a lot of unused CPUs out there. And arguably, SysDig sees quite a bit of these workloads out there. Certainly jives with what we are seeing with the number of customers we have as well. Now, if you are supposed to keep things under budget and you're managing clusters or you're a SRE platform engineer, this slide is for you. Why? Because if you ask any developer how much CPU memory you need, we will always say more. I've been a developer myself. Why? Because you don't want to have any problems in production. So you always overcompensate, right? And then you rarely revisit this. So there's a lot of oversized workloads. I've seen tons when we did consulting, and then with our product. This is an actual problem that almost every organization have, including any startup. Guaranteed, because no developer wants to be blamed for having less resources. Right. So in order to manage or optimize anything, you need to understand what you need to gain visibility into, because you cannot optimize what you can't see. So let's look at what should we gain visibility into, what should we track. Right. Okay. First thing is, let's look at the cluster. I'm breaking it down into 3 regions here. Let's start with the one at the bottom. Is the easiest to explain. This is your overhead. Could be your control plane cost, any kind of licensing you're paying. So if let's say you have a observability vendor, right, who charges by the host, or let's say you're using OpenShift, the licensing cost there. Indirect cost is like your cost of running the SRE platform team. Some people track that as a cost, others don't, but there are some sort of overhead costs, right? Next is the resource allocation cost. This is where your compute and storage. The important part to understand here is the moment it is allocated, it's going to start charging you. The cloud vendors are going to charge you whether you use it or not. And this is where most of the optimizations can happen and where you can save cost. So it's important to keep an eye on this region. The other one is resource usage cost. This is based on your usage. So network cost is the most prominent one over here that's directly related. There could be other indirect costs, but I'm just talking about just purely from a Kubernetes perspective, what we'll be looking at. And here, it's important to gain understanding into network cost as a whole, and then the breakdown. Why? Depending on your volumes, how much you do, this can be significant. For some customers, this is significant. And I'll explain very easily with one example. The best practice is to run across 3 availability zones. The problem with here is, though, if you have a lot of microservices in between and there's a lot of cross-chatter, that can drive up cost. I think in January for us too, we run 3-node Kafka cluster on Kubernetes, pegged to each availability zone. Amazing high availability. but the cross chatter between the Kafka nodes drove off 20% of the bill. It was cross-zone traffic. It's not a trivial amount too. And on AWS, they charge you to going into a zone and out to a zone, so 2 cents per gigabyte. That's important to understand and keep track of it. Right. Now that we looked at the cluster side, let's look at your resource allocation side, because I talked about this is where most of the optimizations can happen. That region, I'm going to break it into two: actively used by workloads and idle. And if your idle capacity is more than 20%, start looking at it. I've seen 30%, 40%, 50% idle capacity, just wasted resources, burning electricity, and the hole through your wallet. So might as well look at it. You cannot have 100% efficient utilization, right? It's impossible. 20% is, in my opinion, okay, because you need a little bit of burstable capacity, even with auto scale and stuff like that. There's reasons. We'll get into that later. So if there's one thing to track this breakdown, idle versus what is actively used. Now, doesn't mean although this is green, doesn't mean this is all good. There's further things you can do there, but at the least track this. Then, once you track that, now you want to work on that green region, right? Now that green region is made up of workloads. So now you got to understand how the workloads are going to cost you. So in Kubernetes, the smallest unit is pod, but resources are allocated at the container level. So look at your container. Understand how your container is going to cost, right? So that's where your compute is there, your network cost is there. So the ability to see this at the container level is important, because then you can sum it up and figure out how your workloads are. So get a breakdown of how much each workload is going to cost, how much its container is going to cost. That visibility helps. Once you have that, well, alongside that, you got to look at the efficiency. The next one is efficiency. This is very important, because this is where you're going to think about right sizing, right? So the way I define efficiency here is how much you're getting for your requests and how much you're using. Because if you look at Autoscaler or Carpenter, they work based on requests. So when you try to schedule a pod, there's not enough memory CPU, what it'll do is it will scale out, right? And you're scaling out, you're now paying to the cloud vendor, but your usage is low. So if it is at the least, try to get it 70, 80%. If your resource is using more than the request, that's fine. But point is, this is a first place to look at when you're looking at container optimization. So the reason why I talked about container or workload cost, because now you can come at a hit list, look at all the workloads that are the most expensive, and then out of that, which ones are the least efficient. Those are the ones you want to go after, because as an SRE platform engineer, you also have a lot of things to deal with, right? And you want a bit of a priority list, so that could be your priority list to start making efficiency improvements. Right, so we talked about that, and this is why it's important. This is not unheard of. I've seen this plenty of times. Most applications out there are memory intensive, barely deals with CPU, but CPU is the most expensive resource, right? Yeah, so track those. Less important, this is when once you figured out your efficiency part, because if your pod is inefficient, number of replicas, that's how much it's going to cost too, right? So first, let's deal with efficiency. Then you can think about how do you optimize the pod count. Yes, you can use K8s and HP and all of that stuff, but it's good to understand where, like a bit of a histogram to understand where your pods are in terms of the number of pods. But like I said, this is useless if you don't optimize your container efficiency. So let's talk about some cost management challenges now that we've gone through the basics and fundamentals. Then we'll dive a little bit deeper. Right, we already talked about it, so I'm not going to spend time, but it's worth showing this picture. I like the guy with the big gun. Then this one, sudden cost increases. This could be due to actual Black Friday volume, or it could be a bad experiment. If it's Black Friday, at least you have the revenue to show for it. But there are plenty of times where people have got sticker shock at the end of the month because someone did something stupid and the workloads scaled up uncontrollably, right? At the least, you need to be notified of these costing. So do something like basic cost alerts from the cloud vendor. But what is really important is when something like this happens, being able to investigate why this happened. To have that data, you need that visibility, right? So things like cost alerts that are more Kubernetes specific, right? It's a bit of a plug for our product. There you go. This, larger companies, right? It's unbelievable. Smaller companies, you generally understand, you can wrap your head around the amount of workloads you have. In some enterprise customers, like people spin up workloads like nothing, forget about it, they don't care. It's just sitting there and chewing up CPU and memory. So idle workload detection is very important. That's a good way to save money. And in fact, I've seen like articles, some organizations just track that down and saved a ton. There's there's two parts to this problem. This is actually probably is becoming worse because with platform engineering, it's all about enabling, right? Like now, some organizations have allowed developers or teams to spin up their own cluster, or they get a whole bunch of namespaces. You know what? People just spin up things and forget about it, right? So this is a problem. Then this, yep, and this is I've spoken to a number of platform engineers, SREs, who are like, we see this as a problem, but development is not prioritizing it, or the other teams are not prioritizing it. I'll talk a little bit more about what you can do here, but most organizations now starting to do chargeback, internal chargeback. So yeah, if you want to do that, great, but we're going to pass on the bill to you with organization politics and everything. This is a more structured way of implementing account, because without accountability, sometimes you can keep teams in check. In case I forget to get to it right on time, if you have any questions or anything like that, you can send me an email, and I'll probably hopefully have this at the end of the presentation as well. Let's look at some cost management strategies now. Okay, good. So I want to bucket them into kind of like three segments. One is about gaining visibility and monitoring, so cost monitoring. And in this cost monitoring column, I'm going to put the cost breakdowns, resource efficiency, kind of metrics, cost alerts by abandoned workloads. I mean, like those idle workloads, dormant workloads. Get that visibility, get that monitoring. Control. This is where you implement right sizing. Some organizations have t-shirt sizing. That's better than nothing. But the problem is, though, without monitoring, that becomes like a one-time exercise. Applications change over a period of time, and you may actually need to up your resources or right size. So there's no feedback loop. That's why monitoring is important to go alongside with right sizing. Resource quotas and limit ranges, especially for larger organizations, this is good because that will sandbox these people from stepping on other people's toes. And limit ranges are also good because it can limit the number of pods. So someone trying to experiment with K8s and spinning up 100 pods, nope. So you can limit those things a little bit. Yes, it does come at the cost of, it's a bit of red tape, right? But at the end of the day, without those guardrails, especially in large organizations, it's hard to control the chaos. So that control part is important. And then finally, the accountability part. It's very important because more and more organizations are trying to make the teams more responsible. And sometimes it's not just about the charge back from an accounting perspective, but people seeing the impact of what they're doing. I'm spinning up all these workloads. Very rarely, developers usually don't care, and maybe they shouldn't, but the management should understand this is the cost of running something, and this is the burden on the ops team or the operating expenses of the company. So a little bit more detailed insight into the analytics, right? For example, this one customer that we worked with, they want to look at what's the cost of running the sidecars, because they were trying to justify moving to ambient mode in Istio or something like that. So they just wanted to see that. And there was no way to figure it out because this is reload zero data, right? So understanding like things like these kind of breakdowns and having this kind of reports and stuff like that can help people make decisions and also hold teams accountable. All right. Okay, if I go over here, there's lots. We don't have a lot of time, so I will only talk about right sizing because others won't do a good job. So let's talk about right sizing. There's two parts to it, cluster right sizing and workload right sizing. Marius did a good job on the cluster right sizing, so I can probably take some liberties here, right? Okay, in cluster right sizing, kind of like the goals, I want to reduce my idle capacity. I also want to choose the optimum node types to save cost. There are different ways of doing it, but the TLDR is probably use Carpenter if you can. But let me break down it a little bit more. There's a good case to be made even in production. You could use Spot instances. You can do both, not just one. There are some workloads that can tolerate disruption. And those are great because Spot instances come at a massive premium. Lower environments, test environments, for God's sakes, use Spot instances. Also, there are different regions that have better pricing. So keeping an eye on that and then figuring it out. Maybe your production, you can move to regions because of compliance and regulatory stuff, but your dev environments can. So think about those things as well. But definitely figuring out the right type of compute for your workloads, because in Carpenter, you can configure that so certain workloads will get pinned onto the spot instances. There's no need to just use just one size fit all kind of thing. There are memory optimized VMs, there are CPU optimized VMs. And it's also, we found out there are some workloads that were pretty memory optimized and our CPU was too much. So we ended up going with some memory optimized nodes. But you also have to be careful in some cases that this can actually limit some of the other workloads and they will start getting throttled on CPU. Or there are some workloads, I don't know if there's in Azure or others, but I know for AWS that has a burstable CPU capacity, because we got surprised with a little charge for burstable CPU when we used a particular type of memory optimized VM. So all cloud vendors have specialized VMs. Have a look at it. Look at your workloads, bucket them, and figure out which workload should go where. And that way you can tune Carpenter with certain things, right? And then you can get better bang out of the buck. And this, large nodes, few large nodes versus lots of smaller nodes. There are multiple things to think here. Jonathan talked about the noisy neighbor problem when you have a lot of smaller nodes, right? There's also other things to think about too. If you have few larger nodes, high, like the blast radius is high, right? High, like the less number of nodes, the higher the blast radius. If you have fewer number, a whole bunch of nodes, and your workloads are spread, you can tolerate more. So there's performance versus, how would I say, performance versus cost, right? Also, licensing costs. Like if you're paying for like an observability vendor, less number of hosts may lower your bill because it's based on per host, right? Per VM, some observability charges like that. Think about all of those angles, and it's not always cost, but those are considerations that you can think about, and then you can figure out how to tune Carpenter, or if you're using cluster autoscaler, like figure out your node pools and stuff like that. So just to quickly summarize, monitor your idle capacity. At the least, use cluster autoscaler, but Carpenter is generally faster and more cost-effective, and Mary's just proved my point today. Thank you. And we'll quickly do workload right sizing. I think I have just about enough time that we're talking about this portion. Now, the gist of this is you got to figure out the right request and limits for your workloads, and that way you can tune the sort of the efficiency, right? And then you want to do this based on observing your workloads over a period of time so that you can adjust for all kinds of variances and stuff like that. And in general, you want to be balance performance with cost, because this happens. I'm not, because you guys are laughing, I know, it was for sure. You know what I mean? Yeah, this happens. So be careful. And when you talk about pod level auto scaling, think about HPA or K8s a lot more, because there are more scalers available. So you can tune more based on your actual load and stuff like that. So I recommend K8s if you can, but think about HPA at the least. If you're going more than 2 pods, think about HPA, nothing worse than going with a static size, unless you're very sure that you're going to get very good utilization for those. Yeah, let me sum it up. Cluster autoscalers work on requests, not limits, so something to keep in mind. That's why that a little bit of idle capacity is useful. Otherwise, there's no burstable capacity for your workloads. If you're not using any other tool, try to use VPA, but with updater mode off. The CRD will contain some right sizing guidelines. Use that. A lot of the vendors, including us, actually use that to get that. So that's a little secret. So this is VPA is free. Use it. Just don't use with update mode on, especially if you're using HPA, undesirable behavior there. The other thing to keep in mind is memory is a compressible resource. Set limits. What that means is essentially your pods are going to get killed if there's no limit set. But you'll be surprised how many production workloads are run without memory limits. CPU is what you call a non-compressible resource. Memory is a compressible resource. With CPU, though, there is a case that you can make to not setting limits, because that allows you to set some requests, but there is a reasonable case to be made on not setting limits. So it allows a little bit more burstable capacity, but for sure on memory. And then just to wrap it up, how do you implement these things? Very quick things, a couple things. Prometheus, Grafana, you can do some basic, just with C-advisor metrics and kube state metrics, you can build a couple things to get visibility into efficiency at least. Open cost, great open source solution to get cost breakdowns and visibility. It's scoped to a single cluster, but you can build something on top of it. I know some organizations with massive 7-figure bills who have used open cost as a basis to build their own cost management solution, or you can use a vendor product like Randoli, and there are others to get the cost monitoring and visibility and other things. So those are the key things that you can do from an implementation perspective. But I would want to highlight this again before I just open up for questions. Just keep this in mind, and it's not just a one and done kind of thing. You want to think about all of these 3 key pillars. If you want to drop one, maybe accountability, but control and visibility and monitoring is like very important in your cost management strategy. I think that's it. It's right on time. Thank you very much. If there's any questions, I'm happy to answer. And please shoot me an email. I will happily answer your questions. And there's a bunch of videos and articles that we have on this topic that goes deep into it. I'm happy to email it to you. Any questions from anyone? Yes, sir. Yeah, you're going to ask a hard question. I forgot this.
Yes. It's a question that I've been asked a number of times, right? The industry seems obsessed with Kubernetes, but is it actually creating more financial waste than value for organizations? And should we really be discussing when not to use Kubernetes rather than trying to spend so much time trying to work out how to make it cheaper?
Great question. So this is in fact one of the key questions that we dealt with when we did consulting in the beginning. I for a number of years, from 2017 until about 2021, we did a lot of Kubernetes migrations for very large organizations as part of being Red Hat service partners. Not all workloads are good to be containerized. So that's the first thing to understand, is this workload even makes sense to run on Kubernetes or serverless or whatever you think it would be. The other thing is, a lot of organizations just blindly migrate sometimes, massive monoliths. Now, if you're scaling that, it's too expensive. So I'll give you an actual case study. This is a Canadian postal service. It's a public case, so that's why I'm okay to talk about it. Instead of taking that big monolith and scaling it, which is very expensive, modernize it, now you can scale in smaller pieces of it. So Black Friday, they have Black Friday and the holiday season, massive load compared to the rest. So before, they were scaling this big pile. But once you modernize it, now you can scale more intelligently, only the pieces that are hard hitting that can be scaled independently. So it's a more cost-effective way of scaling. But to answer your question, absolutely, not every workload is suitable to be run in a container. And yes, it is probably causing more issues, but you're right. Like, that's the first question I would ask, not about how to optimize costs. Before you even get there, we should figure out, is this even suitable to be run on Kubernetes? Yes. Yes, sir.
Your talk is fantastic. Thank you very much for that. The question I have, I suppose, is you mentioned developers and things like that. Do SLOs play a part in the cost optimization as well?
Yeah, I think people are very afraid of failure and stuff like that. So that kind of thing motivates people to err on the side of caution. And if I'm a manager, I'd pay the extra dollars than have a production outage, right? And I think part of the problem is not enough feedback loop, right? So if you're making cost improvements, you have to have your APM and other things that, at least in a way that people can correlate the two. That's one of the key parts of why we think unified observability instead of siloed data points. Very good question, because in the absence of data, people are afraid to make that choice because you don't want to be the one who screwed up production. Yep. Hey, you're welcome.
One more?
Do you think now, with everyone moving to sustainability and carbon footprint metrics, that we need to be using those types of metrics alongside just sheer numbers?
Yes, a lot of the cost management solutions I've seen are starting to put them out. And that's also been talked a little bit in the open cost community as well. The waste, like you said, is not just limited to money, but it is about the carbon footprint and the cost of running these data centers and having all the electricity running up and down. So definitely, I think it's worth. And I think a couple of KubeCons, I even saw very large organizations actually talking about it and making that a priority, and where they track these things for sure. It's a great question, though. We always think about the dollars, not necessarily the impact. What's that? Yes. Yeah, that was actually, someone did that talk based on that project at KubeCon, yes.
All right.
Yeah.
Thank you.
Thank you very much. Appreciate it. Thank you.